Let's try to work on a problem that goes with the final category, which is the case of repeated irreducible quadratic term. Now here you have such a function in the denominator also. Now since this is to the fourth power times this one, the degree of the denominator will be 5 and the degree of the denominator in numerator will be 3, so it is a proper fraction, so we can directly use the partial fraction theories. And you can see this is a quadratic function which is irreducible by that b squared minus 4ac term. So but the thing is, it is repeated, so this portion will falls under the the fourth category, and this one will be just a non-repeated linear function, linear factor. So we should write this term for that non-repeated linear factor, and these two terms for the repeated quadratic term, as it is explained in the fourth category. So by multiplying the two, and then here you will have to do some simplifications. Okay, I have like this method is also given in the book. We can simplify this bracket and separately, and also here we can simplify this one, which is x to the power 3 plus x, and then by multiplying with this bx term it becomes this one, and the same thing when it is multiplied with c, it becomes this one, and then dx and e will go like this. So after that we can write x squared, x cubed terms separately along with their corresponding coefficients, and then we can directly use the comparing coefficient method, because now even in this case we won't be able to find all a, b, c, d and e values just by the method of substituting the roots. Now here of course the substitution method gives a very little help, because here this is the only term that we can consider for a root, which is 0, and by substituting x equals 0, what we can get is this term will get cancels out, this term will get cancels out, and we can only find a, right? And after that we must go for the technique of comparing coefficients. So here we can start with constants, because here you have a constant and here you have a constant, and then for the fourth term, the cube term and the squared term, the coefficients, by comparing those we can find the remaining a, b, c, d and e values. So the partial fractions of the given rational function will be like this. Now there's another thing that I want to mention here. When you present your answer, make sure that it is clearly readable, right? Now don't try to write numbers and simplifications here and there. See, now although it looks like a complicated thing, this is the only answer that you are expected to write. Okay, so it's not a big deal, but if you do the calculation somewhere here and substitute terms somewhere here and multiplication down in here, then everything will be a mess. Okay, so just make sure to present your answer in a neat way. Okay, you don't have to have beautiful handwriting, but please make sure that you have your answer written in a neat way. Okay, not in a mess, right? Okay, so now in the next video we will see the connection between integration and these partial fractions.